Over the last 40 years, global agricultural production has more than doubled, although cropland has increased by only 12%. This result can be largely credited to increased reliance on irrigation. Irrigated agriculture accounts for around 70% of the total water that is withdrawn from the Earth's surface and groundwater. Because irrigation is one of the most important cropland measures, accurate information about the location and extent of irrigation is fundamental to many aspects of sustainable water resource management. As the world's food, water, and energy demands continue to increase, and as research begins to evaluate the implications of climate change for irrigated agriculture, identifying, monitoring, and managing irrigated agricultural lands will become even more crucial. However, the extent and distribution of irrigated areas on a global scale remain highly uncertain. Remote sensing offers strong potential for routine monitoring of irrigation, as satellite data can acquire continuous temporal and spatial information over vegetated surfaces. In general, studies that have used remote sensing to map irrigated lands remain relatively rare due to the complexity of mapping land use as opposed to land cover. In regions where there is limited precipitation during the growing season, abnormalities in plant greenness and water content can generally be attributed to irrigation. The calculation of various vegetation indices provide means of measuring greenness and water content. If performed accurately, remote sensing can offer useful spatial information on the exact locations of irrigated lands, which is important for assessing irrigation performance, quantifying environmental impact, and understanding changes where irrigation occurs. Gathering informational aspects such as these could be particularly beneficial in regard to the Lake Ermia Basin, where irrigation activity is prominent, which is why this is the chosen region for our study. The Lake Ermia Basin, located in northwest Iran, relies heavily on irrigation systems. However, the use of river-fed irrigation canals and groundwater-supplied pressure systems has caused the basin to shrink in recent years. The loss of lake area has diminished the productivity of surrounding agricultural lands and caused substantial economic losses. The purpose of this study is to map out the extent and distribution of irrigated croplands surrounding this region. Irrigated and non-irrigated crops show considerable differences in NDVI for the same crop type or cropping pattern. Irrigated crops exhibit higher NDVI levels, which can be used to separate those from non-irrigated crops. Using 30-meter NDVI data from Landsat 8, high-resolution irrigated maps for the Lake Ermia Basin were generated through running the CART classifier on Google Earth Engine. Identifying spatial and temporal information about irrigation systems of this region may provide helpful information in optimizing water resource management in agriculture and increasing the water use efficiency in Iran, as well as potential restoration of the Ermia Basin.